Hi, welcome to EDU AMP. This is another video which is going on to one I did previously, all about pressure and hydraulics. In my previous video, I showed you to calculate the pressure in liquid using a force acting over an area, but I hadn't done the fact hydraulics and the fact the pressure is constant, and I also haven't covered describing how a hydraulic system can be used, and also is used the pressure equation in hydraulic systems. Now, hydraulics are used in everyday life all over the place. So this is probably most simplistic hydraulic machine you can imagine. So I want to imagine you've got two syringes. You've got A and also you've got B. Now, in the case of syringe A is a small syringe with a small area, and B is a large syringe with a large area. Now, you've got a connecting tube going across here and you've got liquid. So I want to imagine what you're going to do is you're going to push in with a force here. And as you push that syringe in, all the liquid will go through here like this. And it makes common sense that B goes out there. Now, the important thing to realize, because you've got the same liquid connected all the way through here, you've got liquid in here and liquid in there, the pressure in this liquid must be constant all the way through. So you've got constant pressure. And that's the important thing to realize. Now, if you've got constant pressure, you can now start looking at the pressure equation, because you know pressure is simply going to be force divided by area. Now, looking at this one, you've got the force in A, and then you've got the area in A. In this one here, the pressure, again, is going to be force divided by area. But again, now you've got the force in B and you've got the area in B. Now, as I said before, the pressure is constant throughout this. But changing the color of my pen is looking at this here. Can you see this one has got a small area? Now, for what I've done here is draw an arrow going downwards to show a small area. Therefore, if it's got a small area, the force must also be small to balance this equation to make this constant. Going across to this one, you've got the area is larger. So I'm going to do an arrow going up to show a large area, which means then the force must be bigger, because a bigger number divided by a bigger number will make the pressure the same in each one. Now, this equation is sometimes seen in textbooks, but this makes logical sense doing it this way with the arrows. Now, if you really think about it, if this area is going to be twice as big, isn't it going to be 2 times the force? And this is the whole point of hydraulics. Hydraulics make the force bigger. And where we can use these, tragically you get a car crash, the fire brigade can turn up and literally they can use hydraulic cutters to cut off the top, like a can more or less. They cut the car off so they then get to people out as quick as possible and not basically out of danger. Another application shown very shortly is going to be all to do with braking systems. But this is one that you may have seen as a car jack. Now, what you've got here in a car jack is, first of all, you've got all this liquid in green. And this one is a lever device. Therefore, you basically going to be a pivot just here. Maybe turn on a different color to make it easier for you to see. You've got a pivot just here. And what you do is you're lifting that up, which forces that down. Now, what we're saying is you're forcing this down with a force of 50 newtons, pushing this down here, and that's going to go down. Now, if that gets shoved down, what it's going to do then is going to push this piston going to go up. All this is doing here is keeping the liquid constant here. You don't want to lose any liquid tools, like a spare liquid more, is the way you can look at it. So as you push this down, the liquid gets all the way pushed around here and it goes up. Therefore, this load can go up. And one they can ask you in exam questions is, what's going to be the force here on the load? Now, to do that, again, using what we've always done, using formula, working answer units, you first of all state your pressure equation. Pressure is equal to force divided by area. Now, if you've got a 50 Newton force here, in this one, which I'm going to call, well, that's going to base the effort you're putting in, the force is going to be 50. The area here is going to be 10, which means the pressure works out as 5 newtons per centimetre squared. Okay, now this one, you're doing slightly different units because the area is given centimetre squared. Now it doesn't matter, it's not a metre squared, you can just leave it the same units. Now, as I said before, means this one must have the same pressure, which must be 5 newtons per centimetre squared. Now, if you've got the equation pressure equals force divided by area, to rearrange it, force then is equal to pressure multiplied by area. If you like using triangles, the triangle pops out like this. And therefore, if you put your thumb over the force, force equals pressure times area. But you should really try and get into rearranging equations. Now, the pressure then is going to be 5. The area, as I mentioned before here, is going to be 200. Simple mass then, that is going to equal to 1,000 newtons. You can see now you've got a bigger force. The other way of doing it, can you see this is literally 20 times the area. So what you could do as a quick way of doing it is take 50 multiplied by, oops, lost my pen, 50 multiplied by 20 then equals 1,000 newtons. But in an examination situation, you should show the formula working. This can sort of do it in your head and then just double check with your equations going through here, because the examiner does want to see you're working. Another application, it comes in here. And this is going to be in your car brakes. Now the car brakes, what you've got is a lever device here as a pivot. When you want to stop, you put down, and then what you do is you push this forward, and what it does then, it pushes in something called a master piston. Now in a car, you've got liquid then, and you've actually got pipes, and that does then push all the liquid goes through here. Then this is basically your wheel, which is going round and round and round and round. Then what you've got is you've got a braking disc attached to the axle, which also goes round. There's a wheel goes round. Then you've got 2 pistons. There's a piston here and a piston there. As this liquid gets pushed down like this, it pushes that piston in here and that piston in there. Okay, now this means then underneath the car, well, underneath the driver in the car can make something operate at a distance away. And the beauty thing about it is, you can make the force act in any direction depending where the piston moves. Now, what happens here is you make this area is going to be small. Can you see these cylinders are going to be big? And like I looked before, if you have these are going to be twice the times the area than this one, the force then is going to go up by a factor of 2. If you make these 10 times bigger, the force go up by a factor of 10. Therefore, you've got a force multiplier. So what you can do is make this force bigger, because obviously your foot is not to stop a wheel turning around. You've got the pads acting on here, and what they do then is they slow this wheel turning around. And hydraulics are used in car brakes. One thing you may have heard about before is something called bleeding. And what can happen is sometimes you get air bubbles start to form in the liquid. Now you should know that if solids, you can't compress them. Okay, but liquids, you also can't compress them. But gases, yeah, these can be compressed. And the reason why in a gas, all the particles are quite far apart, moving very, very, very quickly in all different directions. And what can happen is you can basically squish them together. So if you get air bubbles in your braking system, you'll find the brakes become spongy. So ever so often, what you have to do is you have to do bleeding to remove all these air bubbles out of the liquid to make the brakes work effectively. And this happens in also mountain bikes. Mountain bikes now have hydraulic systems, and occasionally you need your brakes bled to make sure they don't get spongy. So what I've just been through is I've now explained for you the fact that states the pressure in hydraulics is constant. I showed you hydraulic systems can be used. I've done that in hydraulic jacks, and I've also then done it in car braking. And I've also showed you how to use the pressure equation. Okay, hope you enjoyed the video.